all of you. Good evening. As mentioned, like last session, we will do this exercise 4.5 plus 12 mathematics. So in the meantime, as we wait for more of your friends to join us, you can, this is the fourth question. So you can just get ready with these questions, take out your book, pen, paper, everything, and you can get ready. We'll try to finish up this exercise today. Let's see within that 1 hour mark how much we can complete. And if time permits, then yes, we will try to finish up this exercise so that we can move on to the other important exercise also again. So let's see, people are joining in slowly. Sangeeta, good evening. Imsotila, good evening. Emily Mongla, good evening. Tamsamala, Bandang, Amlari, Mern Banla, Shipong Ranla, Alumnongla, good evening, all of you. Priyanshu, good evening. Imsasanla, good evening. Satyala, good evening. Imtiala, good evening. Imchinba, good evening. Imsanongla, good evening. Cynthia, good evening. Yeah, sorry for late, sir. Dinner was so good I couldn't help myself to stop. Imnasanla, good evening. I wish I envy you. I still haven't had my dinner yet. After this class only I'll have my dinner. Shubhamla, good evening. Students come first. After that only my dinner will come. So students first. You're always at the top of the list for me. So you will be first. After that only I'll have my dinner. Ashley, good evening. Tapojongla, Tinitamsa, good evening. Lanuinla. Lance, good evening. Sapongla, good evening. Yes, so as mentioned, as we wait for maybe one or two of your friends more to join in, this will be question number 4. We will try to finish up this exercise today. Let's see within that 1 hour mark how much we can complete as mentioned. So let's try, you can just, I've done the first part. This is just the first part only, question number 4, verification of that particular theorem, where I had told you that we'll get a theorem. This theorem will be proved in the exercises also. So it's that particular theorem. So this is the matrix given. So I've just found out a determinant that will be for this value. So you can just note down this as we maybe just wait for a couple of minutes. After that, we can begin. So in the meantime, those who have not subscribed, please try to subscribe and please do give me a like also. If you haven't liked the video yet, or you are planning to like afterwards only, okay, that will also do. Lono, good evening. So I guess we can begin, right? Fine then, so let us begin. All right then, good evening all of you. What's up, guys and folks and ladies and gentlemen? Let us begin with our entertainment with mathematics. Chalo. So let's rock and roll. So this is the first question for today, question number 4. Verification of the theorem that we had earlier. Romson, good evening. Verification of the theorem earlier, A into adjoint of A equal to adjoint of A into A equal to determinant of A into I. I represents the identity matrix, so here you'll be representing a 3 by 3 identity matrix. So I've just found out the determinant for you. I hope you have written it down. I'll be rubbing it off now. So determinant of A, we get 11. So now time to get the adjoint of the matrix, and later on we'll combine. But in the meantime, maybe we can just calculate this then. I'll just do it here. So determinant of A into I would be, determinant of A is 11, and I will be a 3 by 3 matrix, 0, 1, 0, 0, 0, 1. So that would be, this is a matrix, so 11, 0, 0, 0, 11, 0, 0, 0, 11. So, okay, one part we have already calculated. So stay tuned, try to finish up the whole exercise because there are some big questions in this exercise, and I'll be giving you some very simple and very easy tricks maybe you might have never imagined also. So I'll be giving you those very simple and very easy tricks to solve some particular questions. Not by the usual, the usual method of calculating inverse or whatever be that. So stay tuned. At the end of the exercises, we have some questions. So I'll give you some tips, or yes, not shortcuts, but these are like some another way of finding out, the inverse when an equation is given to you. So I'll be giving you that particular part also. So in the meantime, let's finish up this. So I guess you've done. Alright, so time to find out the adjoint of the given matrix. So time to find out the adjoint. So in the meantime, I'll just write down the matrix once again. Atan, good evening. So in the meantime, I'll just write down the matrix once again. That was 1, minus 1, 2. For the minor, I need 3, 0. You can just continue. Find out the minor. 1, 0, 3. Minor, and then adjoint. Cofactors, and then we'll go for the adjoint of the given matrix. So alright, shall we do it from here? So M11, so let's do it. M11, M12, M13, M21, M22, M23, M23. So let's calculate. M11 will be 3 zeros or 0 into 0. I hope you're already good at this. So I'm just going to write directly now. So M12, 3 3s are 9, minus plus 2, that's 11. M13, that will be 0. M21, so M21 would be minus 3, 0. So that's going to be minus 3. M22, 1 3s are 3 minus 2, that will be 1. And M23, 1 0 0 0 minus plus 1, that's going to be 1. So, alright, I'll just continue with the minus first. M31, M32, M33. Just to save some space, I'll just calculate the minors also. Minus first, I think. So if you just calculate, that's going to be 2 minus 0, that will be 2, m32 would be minus 2, minus 6, minus 8, and m33 would be 0 minus minus 3, that's going to be plus 3. MCK Young. Alright, good evening. So is that done? Alright, so time to get the cofactors A11, A12, A13. Similarly, A21, A22, A23, and A31, A32, A33. Let's do it directly now. Okay, I'll just write like this so that we don't confuse. So A11, that's fine, 0. A12, 2 plus 1, that's going to be 3. 2 plus 1 is 3, odd, minus 11. I hope you remember. A21, where is 21? Where is 21? So 2 plus 1, 3 plus 3. 2, 2, that's alright, 1. 2, 3, 2 plus 3, 5, odd, so that's minus 1. Okay, I'll slow down. 3, 1, 3 plus 1, 4. 4 is an even number, so it will be 2. 3, 2, so 3 plus 2 is 5, that's an odd number, so minus of minus, okay, I'll just write for once, minus, a quick recap, so minus of minus 8 plus 8, 3 plus 3, that's 3. So that's it. So then my adjoint of the matrix A would be 0 minus 11, 0, its transpose, 3, 1, 1, 2, 8, 3. So the adjoint would be 0, 3, 2, minus 11, 1, 8, 0, 1, 3. Three, 1, 1. 3, 1, 1. Just a moment. 0, 1, 3. This one, 2, 3, 2, 3, 2, 3. Just let me calculate once again. 2, 3, 2, 3. 1, 0, 0, 0, minus 1. 1, 0, 0, 0. Fine. This is 3, 1, sorry, minus 1, so that will be 0, minus 1, 3. It's very confusing, especially from the board. I cannot see everything. Only when you look from straight up, then it's easy for us. Alright, so that's it, done then. So let's now, I'll just keep this adjoint. This is done, fine. So next, let's calculate A into adjoint of A. So what was our, now matrix multiplication. Now again, time to be careful for us, including me at the top. You know how careless I am. 3, 0, minus 2. 3, 0, minus 2, 1, 0, 3. It's multiplication with the adjoint. 0, 3, 2, minus 11, 1, 8, 0, minus 1, 3. Now let's multiply this. We know already what to prove. Yeah, Yamapanda, good evening. So we know what to prove, so let's multiply this. So 1, 1, 1, if you still remember. So 1, 0, 0. We'll need all the fingers and the legs, everything. So 1, 0, 0, minus, minus, plus 11, plus 0. Next 1, 1, 1, 2, so 1, 3s are 3, minus 1, minus 2, ones are 2 minus a plus 6. 2 ones are 2 minus a plus 6. Next, second row. 3 zeros are 0 plus 0 plus 0. 3 threes are 9 plus 0 plus 2. 3 twos are 6 plus 0 minus 6. Next, third row, third element, 1 zeros are 0 plus 0 plus 0. 1 threes are 3 plus 0 minus 3. 1 twos are 2 plus 0 plus 9. So that will give us 11, 0, 0, 0, 11, 0, 0, 0, 11. Perfect. So definitely this was the value that was equal to determinant of A into I. Wasn't it? Right. So that's the proof. We still have one more multiplication to be done. I'm going to do it, or you will do. I'll do, you'll do, okay, I'll do. So next, the second term is adjoint of A into A. So I'll just write here so that after I rub, I don't have to write again. 3, 0, minus 2, 1, 0, 3. Done. I'm rubbing it off. Of course, multiplication you can do it later on also on your own if you miss out some sentences, or you can watch the video again later on, right? The more you watch, the better you learn. So let's multiply again. So up, rub. All right, let's go. Let us go 0. So 0 plus 9 plus 2, 0 plus 0 plus 0. 0 plus, minus 6 plus 6 minus 11 plus 3 plus 8, 11 plus 0 plus 0 minus 22 minus 2 plus 24, 0 minus 3 plus 3, 0, 0, 0, 0, 2, 9. So that would be 11, 0, 0, 0, 11, 0, 0, 0, 11. That is also equal to determinant of A into I. So, okay. So that's it, done. Next, question number 5. Question number 5 is find the inverse of each of the matrix if it exists. In brief only I'm writing. Find the inverse of each of the, not number 5. Find the inverse of each of the matrix if it exists. I'll start with number 5. So the determinant of A, the matrix A is 2 minus 2, 4, 2 minus 2, 4, 3. So the question is only if it exists. You know when it will exist, isn't it? When the determinant, when it is a non-singular matrix, that time only the determinant, the inverse of a given matrix will exist. We still haven't calculated the inverse yet. So now this is you remember the formula? How do we calculate the inverse? A inverse was equal to 1 by determinant of A into adjoint of A, not that elementary row operation method. Now, this is an easier method, so definitely we're going to do this. So for that, let's find out the determinant. So 2 3s are 6, minus 4 2s are 8, minus plus 8, so that's 14. So definitely this is not equal to 0. Okay, so A inverse exists. Now to find out the A inverse, we are going to need the adjoint of the given matrix. So again, let's find out M11, M12, M21, M22. So M11, 3, M12, 4. 2 by 2 is an easy job. No? 4 M12 minus 2, M22, that will be 2. So A11 will be, A12 should be, A21 shall be, A22 is going to be 3 minus 4, 2, 2. So adjoint of A would be 3 minus 4, 2, 2 transpose. So that will be 3, 2 minus 4, 2. 3, 2 minus 4, 2. That's going to be the adjoint of our given matrix. हो गया? Alright, so now time to get the inverse. So that's simple. So A inverse will be 1 by determinant of A into adjoint of A. Determinant of A, what is the value of the determinant of A? Determinant of A was, okay, how much was it? Determinant of A, yeah, I cancelled it. Can somebody tell me what was the value of the determinant of A? Come on, somebody type, give me the answer. Determinant of A, I rubbed it off, sorry. $14, okay, good, thank you. So this is the inverse of the given matrix. If you wish, we can just multiply it inside and get this determinant. So that means I'm going to divide by 14 with all the elements. 14, 2 by 14, minus 4 by 14, 2 by 14. So our resultant matrix should be 3 by 14, 1 by 7, minus 2 by 7, 1 by 7. This is A inverse. So definitely, please tell me, this is much easier, isn't it, to get the inverse, isn't it, compared to that elementary row transformations. Definitely this is a lot easier, isn't it? So that's why I was telling you, you have a very easy method to calculate the inverse. Of course, provided, yes, our multiplication, adjoint, there we should not do any mistakes. Okay, that's the catch to it. All right, fine. Let's try a 3 by 3 matrix. I'm not going to do all the questions like always because a 2 by 2 matrix is already done. So the remaining 2 by 2 matrix, I am sure and I'm more confident than yourself that you can do it. See, in life, it's all about our determination, okay? You cannot do it. These are useless words. You can. Just that you have to be mentally tough. You have to be ready for it. Then everything is possible. Everything is possible. All right. So don't think that you are bad in mathematics. You are never good in mathematics. No, no, no. These are words which students like you should not speak. You are good students. You can do it, yes, but you have to practice. Just overnight, we can't. That's not possible. So if you want to be good, you have to do it. So definitely, I'm sure you will be able to do it. So I'm going to do number 9. So let's get the determinant, because we have to check whether it exists or not. So we have A inverse Determinant of A is -3, so yes, since it's a non-singular matrix, definitely it will exist. So if it exists, what shall we do? Our job is now to get the minors and cofactors. So let's begin. Done? Alright. So let's find out. Alright, let's begin. So that's -1. Next value, 4 ones are 4. Next value, 4 twos are 8. -7, 1. Next, 4 ones are 4. Sorry. So the next value, 1 ones are 1, -6. 1 minus 6, -5. Next value, so it's going to be this out, this out. 2 ones are 2, minus minus plus, 7 threes are 21. So 2 plus 21, 23. So A11 will be -1, this is going to be -4, +1, +5, because minus minus plus 5, isn't it? Because 2 plus 1 is odd again, let me not repeat that. 2 will be 23. Next, M23, 2 ones are 2, -2, -4, -6. Next, 3 1, 1 zeros are 0, minus minus +3. Next, 2 will be 2 zeros are 0, -4 threes are 12. And lastly, this will be 2 ones are -2, -4, -6. So that's going to be +6, 3, +12, -6. Let's do 3. Sorry, 2 twos are 4, -7, plus. So 2 twos are 4, minus +7, that's going to be 11. So sorry, this is going to be -11. Done? So now we can go for inverse. So after calculation, this is what we have. Okay. So as you can see matrix, this particular unit, it's not a very difficult topic for us, isn't it? You just have to be, as I've been telling you right from the beginning, you have to be, just careful with your calculations, multiplications, all those calculations only, because you make a mistake, it's all messed up. Okay? Alright. Alright then, so let's move on to something else. Is there any question that you wish me to do, or we'll move to number 12? So, alright then, so let's move to question number 12. The matrix A is given. Matrix B is also given. Do you wish me to do 11? Shall we do 11? Come on, don't be so silent. Tell me something. We have the whole night, so we can go on doing. Alright then, let's do 11 first. Because the question looks slightly different, so some of you might just say that, see, this guy very clever. Difficult one he did not do. So, so I don't want to leave any doubt with you. So, let's just do it then. Otherwise, you'll start thinking, something is wrong. No? So let's leave no doubts, no stone unturned. Chalo. Of course, it's not going to be difficult because trigonometric ratios, we're not new to it. So chalo, let's, without wasting much time, I should talk less. Chalo. So all will be 0. So simply it's going to be determinant of cos alpha, sin alpha minus cos alpha, because all this will be all 0, whether you expand along column 1 or row 1, it's going to be 0. So minus minus minus, so cos square alpha minus sin square alpha, so taking minus common, cos square alpha plus sin square alpha, so that's going to be minus 1. Remember this, okay? We might need this somewhere, so let's not forget this, because next time we will not take minus common, we will do directly only. So here, of course, taking minus common, cos square alpha plus sin square alpha equal to minus 1, which is of course now equal to 0. So A inverse exists. Alright guys, fine, let's go. Let's go to find out the minor. M11, M11, M12, M13. Come on, So A11. Chalo, M11. So minus again, cos square alpha minus sin square alpha. So as I say, minus 1. M12, 0, 0. M13, 0, 0. M21, along 0 only, 0 0 and 2 2 minus cos alpha and 2 3 0 0 and 3 1 3 1 0 0 and 3 2 3 2 sine alpha and 3 3 3 3 cos alpha 2 3 I always tend to get a mistake with this 2 3 see 2 3 I always I don't know this number is getting here 2 3 I'm always messing up so 3 2 3 2 what am I doing? No, that's fine, sine alpha. So A11 will be minus 1, A120, A130, A210, A22 minus cos alpha, A23 minus cos alpha, A310, A32 minus sine alpha, A33 cos alpha. Minus 1 0 0. Done? Alright, time to get the adjoint now. So adjoint of the matrix A shall be minus 1 0 0 0 minus cos alpha minus cos alpha 0 minus sine alpha cos alpha transpose. So that shall be minus 1 0 0 0 minus cos alpha minus sine alpha 0 minus cos alpha cos alpha. This seems like a symmetric matrix. So then A inverse is 1 by minus 1 into, I'm just writing it directly just to save some time again. Time is very valuable. So we gotta save time, right? We gotta save time. It is very valuable. 1 0 0 0 cos alpha sine alpha 0 cos alpha minus cos alpha. Somewhere it has to be sine alpha. Check the answer somewhere. Where is it that we have gone wrong? A23. This should be sine alpha. You can just check, correct it yourself. Sine alpha. So 0 cos, this should be sine alpha. So sine sin alpha. होता है कभी कभी, तो हमेशा होता है मेरे साथ, तो छोटा मोटा मैं तो ब्लैक बोर्ड में कर रहा हूं ना। तो अपने आप करेक्ट कर लीजिएगा, पीछे जाके देखो क्या मिस्टेक है, कुछ ना कुछ तो गड़बड़ होगा ही होगा, गड़बड़ है। सो you can check for yourself. I think this is not cos alpha 2 3, this one ये होगा पक्का sin alpha। तो जाके पीछे में जाके देखो, कुछ होने से करेक्ट कर लो, वो सब तो आराम से कर लो सकोगे आप लोग। उसके बाद करेक्ट कर लो, आंसर निकल जाएगा, ये होगा आप लोगों का सॉल्यूशन। गड़बड़ है, कुछ तो गड़बड़ है। Yes, M23. So that one you can just check once. I think that one you can just correct it yourself, I hope, right? Because I was just, as I say, since I'm doing on the board, it's kind of difficult for me to, just keep an eye on everything. So those things, of course, you can just kindly pardon me for that. So you can just correct that for yourself. M23 will be the Gorbor. Okay, so that should be sin alpha. So you can kindly correct that. Okay, I think you can excuse me with that. Alright, okay, so forget about that. Past is past, so we don't live in the past, forget about it. Alright, making an excuse for myself. Chalo. Let's move on now to 12. The matrix A is given 3 7 2 5. Matrix B is given, matrix A is given 3 7 2 5. Matrix B is given 6 8 7 9. 6 7 8 9. We have to verify that AB inverse is equal to B inverse A inverse. I gave you actually this theorem when we were doing invertible matrices. So we're going to prove that using an example. So you have to find lots of inverses then, AB, because you have to find the inverse of the matrix formed by the multiplication of the matrix A into B. Let's get this AB first. The product of A into B. 3 7 2 5 6 8 7 9. So this product shall be 3 6 are 18 plus 7 7s are 49. 3 8s are 24 plus 9 7s are 63. 2 6 are 12 plus 7 5s are 25. 2 8s are 16 plus 5 9s are 45. So that will be 9 17 1 11 4 5 6 7 8. This one 5 6 7 3 4. And this one 11 4 5 6 61. So this is AB, product of the matrix AB. A into B. 67, 87, 47, 61. So I'll find out the determinant of AB. This is a matrix now. We have to find out its inverse. So we have to check the determinant of this matrix now formed by the product of AB. So this is not two different matrices now. It has been combined now. Two lovers forever now. Alright, soulmates. Alright, so that's going to be okay. 67 into 61, bapre bap. 67 into 61. I'll use calculators. 4087. I'm not going to lie to you that I'm using calculators. What should I lie? Why? 4089. Minus 2. Not equal to 0. So AB inverse exists. Alright, so since AB inverse exists, time to find out the minors and cofactors of the matrix AB. So M11, M12, M21, M22. So 61, 47, 87, 67. So A11, 61. A12 minus 47. A21 minus 87. A22, 67. So therefore, adjoint of the matrix AB, 61 minus 47 minus 87, 67, its transpose. That will be 61 minus 87 minus 47, 67. Okay, now I rubbed it off. It's okay, now. I rubbed it off. It's okay, now. It's okay, now. Chalo. So AB inverse will be 1 by determinant of AB into the matrix 61 minus 87 minus 47, 67. So that's going to be 1 by minus 2 determinant of 61 minus 87 minus 47. Since these are all odd numbers, sorry, this is a matrix one. What am I doing? So let it be as it is. Let's not divide by minus 2. Alright? So keep a track of this. I'll be needing that. Okay? So AB inverse is already done. Now time to find out A inverse and B inverse again and get the product. It has to be equal. Alright, let's go. Where? I mean to the problem. So now let's go for finding out A inverse. For A inverse, let's get its determinant. Can we manage like this? A inverse, B inverse. 3 5s are 15 minus 7 3s are 14, 1. So A11 directly I'm doing. A12, A21, A22. Let's try to find out the cofactors directly. Now let's try to move a level up. Okay? So whatever be the value, this is going to be minus. This is also going to be minus. So let's calculate. A11, that's 5. No problem. A12 minus 2. A21 minus 7. A22 3. So adjoint of A would be 5 minus 2 minus 7 3. Its transpose. So that will be 5 minus 7 to 3. So this is my adjoint of A. So A inverse would be, what was 1? 1 by 1. 5 minus 7 minus 2, 3. So 1 by 1 is 1. Okay, just keep it 1 by 1, no problem. Time for B inverse. For B inverse, let's get its determinant. 6 9s are 54 minus 7 8s are 56 minus 2. Here also let's try to find out the cofactors directly. So 1 1 9 1 2 minus 7 2 1 minus 8 2 2 6. Adjoint of B, 9 minus 7 minus 8 6. Transpose. So 9 minus 8 minus 7 6. So B inverse 1 by minus 2 into matrix B 9 minus 8 minus 7 6. Oh buddy. Done. Baap re baap. So this is our matrices. So now again time to get the product. This is a small but very effective question. Just like a small mosquito giving us a problem, no? Small question but not small. Again, not to multiply. So minus 1 by 2 into 9 minus 8 minus 7, 6 into A inverse to 5, 1, 1, 1 only, minus 7, minus 2, 3. Minus 1 by 2, let's go for the product. 9 5s are 45, minus 2 8s are 16. 9 7s are 63, minus 8 3s are 24. 7 5s are minus 35, minus 12. 49 plus 18. Minus 1 by 2, 11 4 5 6. Minus 87, minus 47. 17 4 5 6. (61) minus 87 minus 47 for 67. So I think the verification is there. You can check and confirm for yourself. Is it verified? Somebody, if you have checked, please give me yes sir. So this is AB inverse. Is it? Of course, without your consent, I just wrote. Is it correct? Somebody come on, give me a check and then tell me, is it correct? Just a yes will do. Yes, sir. Thank you, Lance. Alright then, so that's it. I mean, that's it for, not for today, that's it for this question. Wow. So, we're moving. Even if we want to move very quickly, we can't, isn't it? Because the questions are like that. Anyway, no problem. Now we have the whole night. You have had your dinner. I haven't had my dinner. No problem. We have the whole night. We can go on. So, alright then. So, time to give me something back so that I will know that you're still alive. So, come on. Give me what? Give me a love today. Come on, let me see how many of you can give me a love. How do we do that? Like this or something like this? Or what do we do it? I have seen people doing these days, something like this. That shows the heart, isn't it? Something like that. So come on, give me a love today or something else. Something different. Okay, how many of you given me loves? Love, love, love. Love is on the way. Okay, we call it what? Surrounding. Okay, that's understood. Alright, so I was just wondering what do we call this and also what do we call it? This one like this, isn't it? Okay, we call it what? Surround. What does it mean? What does it mean actually? This surround or what do we call it? It means mushroom or what? This one sarang means mushroom because somebody just sent me a mushroom. Okay. Sarangi. What do we call it? Sarangi. Sarangi. Okay. Sarangi means love you in Korean. Alright. Okay. You love me. Ah, so sweet. So nice. So cute. You see? Alright then, all of you, my dear students who are all watching here or learning, Sarange! It's alright, doesn't matter. It doesn't matter from who. See, love can be of different forms. Love can be in so many forms. So it can mean a lot of things. That's why I'm also telling you, Sarange to all of you. So even the boys also, Sarange. So love can be it can be of different forms, isn't it? Love can be of different forms. It can be of respect. Alright then, so time to get away from now Sarange. Let's go to matrices, no? Alright then, thank you so much. Alright, let's continue then. This one, I'll give you a trick on how to find out this A inverse without finding A inverse. That's usually in graduation courses and all. Here also we have, but actually we don't learn that actually. So, but graduation courses and all, we have this. So I'll be telling you how to find out the A inverse. If an equation is given to us, we can actually do it. But first, let's try to verify this. All of you know how to multiply and all, multiplications and all known. So let's continue without waiting for me. Let's quickly move to it. So I'll just start with the equation a square. So a square minus 5a plus 7i is equal to, we have to verify it. Remember, a square doesn't mean square of matrix. You remember? I have told you about that very strictly. They do that. Many students, they do that. We can't do that in matrices. It has to be multiplied. Minus 5 times of matrix A, 3, 1, minus 1, 2, plus 7, 1, 0, 0, 1. So let's continue. So that's going to be 3, 3, 3. So 3 3s are 9, minus 1, minus 3, plus 2, minus 3, minus 2, plus 1, minus 4, isn't it? 3 3s are 9, minus 1. 3 1s are 3, minus 3, plus 2. Minus 3, minus 2, plus 1, minus 4. Minus, multiplying 5 2s are 15, 5 1s are 5, minus 5, 5 2s are 10. Then I actually represents identity matrix of the order which you are dealing with. So this is a 2 by 2 set, so it's going to be 1 0 0 1. So 9 minus 1 8, minus 1, minus 5, minus 3. Minus 15, 5, minus 5, 10, plus 7, 0, 0, 7. That's 8, minus 15, plus 7. Just adding up all the equations together. Minus 5, plus 5, plus 0. Minus 1, minus 5, I think I wrote this wrong. This is plus 1, I guess. There, I think I've made a mistake there. As usual, there's nothing new there. Me making mistakes. So 3 3s are 9, minus 1, that's fine. 3 1s are 3 plus 2, that's fine. So minus 1. Now this and this, no problem. Here only. Minus 1, minus 4, this will be minus 5. And this is going to be 5. So with this, what happens is minus 1 plus 4, minus 1 plus 4, so that will be 3. So that is done. So this will be minus 5 plus 5, no problem there. Next will be 3. So this would be again 5 minus 5, 5 minus 5 plus 0, 3 minus 10, 3 minus 10 plus 7. So that's 15, 15, 0, 5, 5, 0, 5, 5, 0, 10, 10, 0. So fine, and this is the proof of the given equation. Alright, so that's the proof of the given equation. Okay. Alright, so next we have to find out A inverse. It's a 2 by 2 matrix, so you can directly find out the A inverse also if you wish. But I'm not going to do that. You know, I'm very lazy, isn't it? So I'm going to do it in a very different way today. Remember in the beginning of the class I told you that we are going to do something very interesting today. So, but before that, let's just check whether A inverse exists or not. Because the matrix A was, otherwise we cannot find out, huh? 3, 1, minus 1, 2. 3, 1, minus 1, 2. So, of course, you'll do it in the main copy. Since I've already written it there, I don't want to be rubbing it off again. 3 to the 6, minus plus 1, that's 7. That's not equal to 0. So, yes, A inverse exists. So now A square, I will write A into A minus 5 into A is equal to minus 7 into I. Treating it just like an equation. Okay. Remember, my job is to find out A inverse. So what I'm trying to tell you here is we are going to have a different, because an equation is given, that's why we'll do it in a different way. What we will do is we will post multiply, that is post multiplying by A inverse to both sides. Post multiplying to A inverse, that is 5A A inverse minus 7I A inverse. That's called post multiplying, that side. Okay, this is a term that we use in matrices. So we use this post multiplying, we use this pre multiplying. So post multiplying. And if I was pre multiplying, then that time A inverse will be here in the front. Here in the front. Okay, so I'm just post multiplying. So then that's going to be A inverse minus 5A inverse minus 7A inverse, because A inverse is I, also I into A inverse is A inverse. These are just universal facts we have already seen while doing what? Invertible matrices. So that's going to be AI minus 5I is equal to minus 7 into A inverse. So that means I'll just do it like this equation. That's going to be, so A inverse will be, AI will be A again, 5I. Because A into I will be A only. So A inverse equal to minus 1 by 7 cross multiplying. Got that? So this is a way to do it. So that's going to be minus 1 by 7. A. What was A? 3, 1 minus 1, 2. Of course, for a 2 by 2 matrix, it is, honestly, it's not very helpful the way I feel, because 2 by 2 matrix is a simple matrix, so we can do it very quickly also. But this kind of solving is very, very useful in when you're solving a 3 by 3 matrix, okay? because 3 by 3 matrix we have seen it takes some time. So it's very useful, especially some of you might be already thinking that, come on man, it's already taking a lot of time. Yes, I do admit that. Because it's a 2 by 2 matrix, so it will take the same amount of time like a 3 by 3 matrix only. I mean, like just to find out the inverse only. But it's very useful, that's how we get this A inverse without actually calculating from the equation. But it's very useful when you use a 3 by 3 matrix, then we save a lot of time, okay? But remember, yes, only when the equations are given. Of course, negative sign you can just multiply, so that's going to be 1 by 7, 2 minus 1, 1, 3. So that also you can do, no big issue. Of course, if you are told just no, you have to do by, just the method and alright, no problem. If you have to find out A inverse by A inverse method only, then if your teacher tells you, then no problem, it's all the same. I'm just giving you another method only, okay? No method is wrong, every method is correct, so you can do it in any way. I'm just giving you another tool only so that you will all not be left unaware, that's all. You can go for A inverse directly also. Alright, my dear students, Sarangi. Alright, so the remaining questions are almost the same. Okay, let's quickly do 14. So how long has it been? Okay, we have 5. Then we'll do now just 2 more questions, that is question number 14 and maybe question number 16, because 15, 16 they are alike, it will be same like the one that we have done, question number 13. So we'll just do 2 more questions. Alright, be with me. Okay, are you with me? So this time what shall I ask? So this time what will I get? This time, okay, this time you give me whatever you want. This time you tell me whatever you want. I'm giving you this very rare moment of, expressing whatever you feel like about me. Very rare moment. Today is what, 28th of May, I guess. 28th of May. Yeah, 28th of May, isn't it? So I'm giving you this one chance to express your feelings today. So tell me what you, next week, can just give me anything. Okay, Bindang Amlari, she feels water for me. Okay, I do not know what that means. Okay, she feels water for me, for you. Okay, Romson, he feels kumsumita. Okay, I have really no clue what that is. Okay, absolutely no clue what that is. Kumsumita. In the meantime, I'll have a sip of water so that if some very hot messages come, I'll be cool. Okay, thank you in Korean. Thank you so much. Okay, I'm cool. Yes, I just drank water, so that's why I'm cool, I guess. Of course, definitely I'll be working very hard. I'll be working more again because you people have really motivated me a lot. Okay, so definitely. In the meantime, I'll just write down that question. After that, I'll come back with anticipation to see what you have written. But definitely, to be honest, I'm working hard because you motivate me a lot. Okay, and experience has taught me one thing, that is to be humble always. No matter how educated you are, how talented you are, simplicity and humbleness, of course, is the most important thing for any human being to grow. And yes, we have to sometimes let go of our comfort zone. Then only, we learn new stuff, so we learn new things. Because as long as we remain in our comfort zone, we never learn actually. Alright, it's time to see what you have thought. Thank you in Korean, I guess. Okay. Gam Shaha Binida. Okay, I have no clue. Please let me know in English. Okay, I'm on fire. I've definitely. That's why I drank water actually. Alright, thank you so much, Alumnonglam, for that. Yo man, John Cena is here. Okay, John Cena. I was a big fan of John Cena. I've lost track because, you know, your thumb is the longest finger. Okay, I have no clue what. Okay, your thumb is the longest finger. Okay, that's fine. Okay, some messages I really cannot understand. I cannot really get what you really mean. But anyway, I think definitely whatever it is, I welcome all of that. All right. So, all right then. I guess that's all for. Fine then. Let's continue then. I guess that's all that you have to share and tell me. I was expecting for more, but I guess I don't know. So anyway, let's continue. All right then. Next question, number 14. John Cena is here. Pam, 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 pam. No? Something like that, isn't it? Da, 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 da. How do we call it? Okay, this is the question there. Matrix A, find the numbers such that A square. Okay, this is just an equation that we'll have to solve. So let's solve A square. I'll do it directly now. Is equal to 0. So again, let's multiply. 3 3s are 9. 2 1s are plus 2. 3 2s are 6 plus 2. 3 plus 1. 2 plus 1. Plus 3a 2a a plus b 0 0 b is equal to 0. That will be 11 8 4 3 plus 3a 2a a plus b 0 0 b is equal to 0. Simple question actually, this one. Alright, so that will be 4 plus 3a plus b. 4 plus a plus 0. 8 plus 2a plus 0. 3 plus a plus b is equal to 0. Here also represents a 0 matrix. So equal matrices. So to get the values of a and b, I'll use it as 0 matrix. So now from equality of matrix definition, in short only, once the teacher gets the idea, I think that should be enough. From equality of matrices, we have to move up from the theoretical stuff, stereotype ways, no? Okay, I did not solve the 0, but anyway, doesn't matter. I need to find a and b only, so anyone I can use, no problem with that. So maybe I'll just use this one. So 8 plus 2a is equal to 0, so 2a is equal to minus 8a equal to minus 4. And b I need, so I'm going to use 3a plus b is equal to 0. So 3 minus 4 plus b is equal to 0. So minus 1 plus b equal to 0, so b equal to plus 1. So our job is just to get the value of a and b. So a is minus 4, b is 1, job done. Alright folks, what's up? The sky is up, the roof is up, the ceiling is up. Okay, done. Chalo, let's move to question number, ladies and gentlemen, weighing in 780 pounds. We'll move on to question number 16. 16. Chalo. Same way, but this time, we have cube. So maybe I'll just find out a square first, because in the equation number 16, let's save some time, I'm doing it directly. So a square I'll find out first. 2 minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. Then a cube, okay, a square will be this into this. 2 minus 1, 1. Minus 1, 2, minus 1, 1, minus 1, 2. And a cube will be then a square into a, whatever value we get, into the matrix A. 2 minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. So I've already calculated this in advance because I knew that this was a very big question. So you can try it for yourself, you can check out for yourself later on. Okay, just to save some time, I've already solved this particular question for you. So I'm just going to write on the values now. You can multiply it later on also. Alright, you can check for yourself. So 6 minus 5, 5. 6 minus 5, 5. Minus 5, 6. Minus 5. 5 minus 5, 6. 5 minus 5, 6. 6 minus 5, 5. Minus 5, 6. Minus 5. 5 minus 5, 6. That's the square, and the cube would give me 22 minus 21, 21. Minus 21, 22, 21. 21 minus 21, 22. Actually, I calculated this in advance, as I said, because I knew that this was going to take a lot of time, so that's why I've just calculated. But you can just check, multiply for yourself and confirm whether it's correct or not. If it is not, do let me know. Okay? Alright, done. So I'll be rubbing it off. Now we can go straight to the equation then. So now we have to solve a cube minus 6 times of a square. A cube minus 6 times of a square plus 5a plus 11i. We have to prove that this is also again equal to 0, a 0 matrix. So done, no? So a cube 22 minus 21, 21 minus 21, 22, 21, 21 minus 21, 22 minus 6 times of a square. I'm going to do it directly. 36 minus is already there. Don't subtract again, don't multiply it by minus. I'll be just multiplying it by 6 only to the matrix a square. Okay, 6 minus 30, 30 minus 30, 36 minus 30, 30 minus 30, 36 plus 5 times of a. So matrix A minus 5 2s are 10, minus 5, 5. 5 2s are 10, minus 5, 5, minus 5, 10, minus 5, 5, minus 5, 10, plus 11i, 11, 0, 0, 0, 11, 0, 0, 0, 11, because this has to be a 3 by 3 matrix. So now let's add up and see. 22, 32, sorry, this was 9a, not 5a, plus 9a. I wrote the wrong question. I was dealing with 9, so 9 twos are 18, minus 9, 9, minus 9, 18, minus 9, 9 minus 9, 18. Yeah, 9a minus 4i. What am I doing? Minus 4i. Minus 4i. 4, 0, 0, 0, 4, 0, 0, 0, 4. I guess that's fine then. I got mixed up with question number 15, no? So can we do it directly here and just check 22, 18, that's 40, 36 minus 40, no problem there, 0. Minus 21, 30, 21, 30, that's also 0. 21 minus plus 9, 30 minus 30, that's again 0. Minus 21 minus 9, 30 plus 30, 0. 22, 40 minus 36 minus 4, that's also 0. 21 minus 9. Come on, this is minus 21. 22 minus 21 minus 21 minus 21, 22 minus 21, yeah, so minus 21 minus 30 minus 30 plus 30, that's again 0. 21 plus 30 minus 30, 0. Minus 21 minus 9 minus 30 plus 30, 0. 22, 40 minus 36 minus 4, 40, fine. So this is also a 0 matrix. A 0 what? 0. 0 matrix. You done? So that's it. That's the proof. Alright. Okay, time to get the A inverse. So time to get the A inverse. So I'll just do that method which I gave you earlier. That'll be easy. You can check for yourself. 3 by 3 matrix. So 2 minus 1, 1. Let's get the determinant first, because after that we will know. Minus 1 minus 2 minus 1. Hopefully I'll not make any mistake. 1 minus 2, 2. So calculating, that is 2 into 2 2s are 4, minus 1, minus plus 1, directly now. Minus 2 plus 1 into 1 minus 2. So that's 2 into 3 plus 1 into minus 1 plus 1 into minus 1. So 2 3s are 6, minus 1, so that's 4. That is definitely not 0. So therefore A inverse will exist. Therefore A inverse exists. Now A cubed 6a squared 9a equal to 4i. So again post multiplying by A inverse on both sides. So that's going to be A inverse. Okay, I'll just arrange and write down for your own concept. So A cube, A into A minus 6A into A. minus 6 into A inverse A. No, minus 1 for A inverse. So A square minus 6A plus 9I is equal to 4A inverse. So A inverse is 1 by 4. A square minus 6A plus 9I. A square minus 6A plus 9I. Definitely this is an easier way, because here what happens is A square and all we have already calculated earlier. So you don't have to do it again. Okay. So let's calculate then A inverse. That's going to be 1 by 4. So A square was what again? A square was 6 minus 5, 5. 6 minus 5, 5 minus 5, 6 minus 5, if I'm not wrong. Yes, 5 minus 5, 6. 5 minus 5, 5 minus 5, 6. Minus 6 times of A. So 6 times of A, I'll do it directly now. 6 times of A. 6 2s are 12. Minus 6, 6. Minus 6, 12. Minus 6, 6 minus 6, 12. Plus 9 times of I. 0, 0, 0, 9, 0, 0, 0, 9. So then we have 1 by 4. Let's calculate 6 plus 9. 15 minus 12, 3. Minus 5 plus 6, 1. 5 minus 6 minus 1. I'm just doing it directly. I hope that's all right. 1, 3, 1. Then again 5 plus 6, that's again going to be 5 minus 6 minus 1. 1, 3. 6, 9 plus 6. 9 plus 6, 15 minus 12, 3. So this is our inverse. So finally we have solved the question. So we are all successful. Alright, so that's it for today. So thank you so very much all of you for joining in, being a part of this class for almost 2 hours. You have been here. I really admire your focus and concentration. Okay, so yeah, alright then, a big thank you to all of you, and finally all of you, sarange.